We are diving into today's section is function notation. The kind of key thoughts I want you to have in the back of your mind is, what is the output? How is it found? Okay, so as we're digging into this, we are going to look at this in terms of graphs or equations. So, first of all, we need to define what the heck we are talking about with this function notation stuff. So, function notation. Function notation is a way of writing an equation so that input and output are easily visible. In terms of what we are familiar with, input will be the x, and output will be the y. Okay? Now, part of this function notation language is we are essentially naming each equation. So, for example, we might call something f of x. F of x. That's how we would pronounce that. The nice thing about calling something f is that we can give different letters to different functions instead of everything just be y equals y equals y equals y equals y equals y equals y equals. We can say f of x, g of x, h of x, m of x, n of x, k of x. You understand, there's like 26 options. Probably closer to like 22. There's some letters we won't use, but not important. The nice thing is we have names for functions and it helps us identify them. So for example, f of x might be the name of our function. In this case, we might write f of 2 is 3. That's how we would read that. Here's what that means. When I plug in an x value of 2, the equation equals 3, the y value. Okay? So let's look at a couple examples. Given g of x equals x minus 2, find g of 0. Now here we go. This right here is the input. It will replace x for us. So here we go. Our g of x is negative x minus 2. We are being asked to find g of 0. So we are going to put parentheses wherever x was. Parentheses are going to be so important. Wherever x was, 0 will go. Now, there's a rule here, and that rule is don't touch the left side. Don't touch the left side, don't touch the left side, don't touch the left side, don't touch the left side. The left side is going to stay g of 0 until we're done. Right? Just like the left side up above says f of 2. So g of 0, this is very exciting because negative 0 is just 0 minus 2. So g of 0 is negative 2. Here's what that means for us. 0, negative 2 is an ordered pair for g. Okay, let's do another one. Now I'm talking about a different function, different name, right? Just like you all have different names, this one has a different name. This function is called f. So, given f of x equals 2x plus 3, find f of negative 1. Negative 1 will be our input. Wherever x was, negative 1 will go. Do not touch the left side, but here we are, off and running. I'm throwing blank parentheses because I know that I'm going to put something in those spots. Wherever I see an X, I am going to put a -1. F -1, don't touch the left side. Don't be a bum. Leave the left side so that we can see what the input was. PEMDAS, multiply before you add. -2 plus 3, 1. Again, if you want to flip this and kind of talk about what this means, it means that when the X value is when the X value is -1, the Y value is +1. Okay, here's what I want you to do. I want you to pause me right now, and I want you just to look at this and say, what do I understand? What do I not understand? What are my notes missing? What do I need to add to my notes? Do I have this all written down in my orange note packet? You should be taking notes. Remember, your tests are basically open notes. Write this down. Okay. We're jumping now to the second half of our work. And for the second half of this work, we're kind of going to change our vibe here a little bit. We have two graphs here. We've got graph F and graph G. Remember, that's part of function notation is we name things. So this right here, with my kind of orangey looking color, that is my graph F. I'm going to make G with my green. So now that I've talked about those graphs, remember some of the key language that we talked about. This G right here, this number in the parentheses represents the X value, and the letter tells us the name. So the very first question is a G question, G of -2. So here we go, G -2. Here's -2 on the X-axis, and I'm going up to see where G's at, and I'm going to say it's about 5.5. Okay, my next problem is another G problem, G of 4. So here's where X equals 4. I'm going to rise up. When you're living on your knees, you rise up. And I'm going to go to the graph. At this spot on the graph, Y equals 3. The next question, hopefully you are catching on, is an F question. And it says F of 7. So I need to go where 7, and 7's hiding, but we got this, where 7 is on the graph. 7, for 7, Y equals 4. Another F question, F of 0. Ooh, 0, kind of a fun one. Here's 0. Here I'm just following the axis up. Y equals 5. And then, to be complicated, this wraps up with a G question. G of 10. Oh, fun. So 10's way out here. Whoops, that's the wrong color. G is our green. Here's 10. Don't have very high up to go. Y equals 1. Take 30 seconds. Pause. Write down what our steps are for when we are reading it off of the graph. Ready? Go. Here's what I wrote. Find X value on the X-axis, right? Look at all those little circles we drew on the bottom. Then we move to the graph, right? We rise up to the graph, and then we determine the Y value at that spot, and that's where we got our answers, right? That last number here, in each of these, that represents Y. Okay, so there's kind of how we do it.